We start with a point.
Hi, it's Rob Bryant and welcome back. Today's entry is called The Big Bang is an Illusion. Now there's a series of images you might remember from a blog I published a year ago that we're looking at here. The blog was called What Would a Flatlander Really See? Now the first image on the left shows what an imaginary 2D flatlander, in this case our one-eyed Jack, looks like to us as we 3D creatures look down from above. Above is a word that would make no sense to a flatlander, since his world has only length and width. As we move right through this series of images, we are imagining rotating our point of view down into the plane that the flatlander exists within. And although there are 5 images here, we should understand there's a 6th image, which would be a line with no depth, something that we could never see with our 3D eyes. The point here is that the flatlander, who we're going to assume has a visual apparatus that is somehow able to deal with these lines, would live in a world where everything appears to him as nothing but lines all in the same plane. In Hypercubes in Plato's Cave, we looked at an animation of a tesseract, a 4-dimensional cube, and we discussed how what we see is really just a representation of a 3-dimensional shadow of that 4D object. A still image of a tesseract or hypercube is much less useful in helping us to imagine it. We have to click play on the animation for what is unique about this shape to become apparent. The ways that it appears to change shape as we view it using the 4th-dimensional direction of time defy reason for a 3-dimensional object, in exactly the same way that the lines a flatlander would see as a 3D object passes through his plane would appear and disappear in ways that would seem very strange indeed to the flatlander. In The Past is an Illusion, I talked about a fun little flash game called Xerox, which you should try if you'd like to spend further time considering how a flatlander might be able to puzzle out the 3D shape of an object as he watched it pass through his plane, but this would be much harder to do with an object like a human, who is moving around, than it would be with a simple object like a balloon. Where am I going with all this? Here's the point. Something that may be a simple or symmetrical shape when viewed in one spatial dimension will appear to behave very strangely when viewed from a dimension below that one. Which takes us to the Big Bang. Here's what I said in my book about the Big Bang. If we can agree that our conception of time as a one-way arrow is an illusion created by our unique point of view, then ultimately we can come to the viewpoint that the Big Bang is also an illusion, as it is just a side effect of collapsing the 10th dimension with the very first yes-no. The point at which we enter the 10th dimensional system becomes the Big Bang, that is to say, the beginning for the dimensions below. The currently accepted version of the Big Bang is known as inflationary cosmology, in which it is proposed that the size of the universe increased by a factor greater than 1,000,000 trillion trillion in less than 1,000,000th of a trillionth of a trillionth of a second. Does this mind-boggling amount of sudden inflation not sound more like the flipping of a gigantic yes-no toggle switch? When I originally wrote those words, I had not heard of a branch of science called digital physics, and I had not read anything by quantum computing expert Seth Lloyd. As it turns out, though, the point of view I expressed back then is very similar to their schools of thought, and can be summed up with 3 words I've used many times now. Information equals reality. This gives us a very useful way of imagining what the Big Bang really represents. It tells us that within the extra dimensions there is a comparatively simple pattern representing the wave function of all possible outcomes for our universe which, just like the flatlander images at the start of this blog or the animation of the rotating tesseract, appears to do something impossible when it's perceived within the dimensions below. Before it slid into view, time did not exist, and when the universe ends, time will not exist again. And as we've discussed in entries like Time in Either Direction and Scrambled Eggs, this reflects the viewpoint of physicist Sean Carroll, who says that before and after the universe is the same thing, a perfectly balanced symmetry state, and our universe from its beginning to its end is just a temporary deviation from that state. In my blog entry, How to Make a Universe, I worked through my description of the 10 spatial dimensions in reverse order as a way of visualizing how this process of our universe sliding into view from a higher dimensional pattern can be equated to moving through the multiverse landscape to other different initial conditions starting points within the extra dimensions. This is a process that could create our own universe, or it could create other universes very different from our own. Is the Big Bang an illusion? Viewed from the place where the distinction between past, present, and future is meaningless, that would be true. This is why I prefer the digital physics viewpoint, that the Big Bang really starts with the first binary yes-no, that begins to choose a universe from out of all other possible universes. And after publishing my book, it was great to come across quantum computing expert Seth Lloyd expressing the same idea in his book, Programming the Universe. What do we call the selection pattern that chose our universe from out of the omniverse? Whatever name you give it, that selection pattern exists. So let's go back to that list again now that I was talking about, working through the hierarchy of dimensions as I portrayed them, but this time moving from the top down. 10 would be the timeless omniverse, the enfolded and perfectly balanced symmetry state, unobserved indeterminacy. 9 would be big picture memes, ways of organizing, grouping, subdividing the information that becomes reality, including those which cannot be expressed as physical realities. 8 would be ways of expressing mass and energy that encompass multiple, oscillating, or changing basic physical laws. 7 would be ways of expressing mass and energy that encompass a single sliding constant, and this would be the 7th dimension as a line. Since certain physicists believe that they have evidence that the speed of light for our own universe may have varied slightly since the very distant past, this line may be really a way of describing our universe. A single unmoving point within the 7th dimension would be a way of expressing mass energy where the fine structure constant and all basic physical laws are locked in from the beginning to end. And our universe is generally believed to be one where this locked-in quality is the case. The fact that string theory says our universe is created by the interaction of a 7-dimensional brain interacting with a 3-dimensional brain within a Calabi-Yau manifold seems to be an interesting tie-in to my concept of our universe being locked in at the 7th dimension. 6 would be all possible timelines for the universe we've created, including ones that will never actually be observed, but which remain as potential. 5 would be all branching timelines, both forward and backward, from the particular point that we call now. The idea that our 4D universe comes from the 5th dimension comes up again and again with this project. Thinking back to how we created our universe, the branches from the very first point, then, would be the same in both the 5th and 6th dimension. But for every other quantum frame, the 5th dimension would not be able to include every possible expression contained within the 6th dimension because of the limitations introduced by choices and outcomes that had already occurred within our space-time tree. 4 would be one very specific set of frames, from the Big Bang to now, or in the biggest picture of all, one very specific timeline out of all the possible timelines from the beginning to the end of the universe we created. 3 is a specific expression of the 3D space that is a quantum frame as per our description above. 2, a specific expression of one of the 2D planes that can be contained within the quantum frame we're examining. And 1, a specific expression of one of the 1D lines that can be contained within the quantum frame we're examining. 0, not a dimension, but a point of indeterminate size, which could be infinitely small as in geometry, or could be infinitely large, encompassing, in the most extreme case, all the dimensions. Some people like to think of the 0 as time. Some like to call it the quantum observer. Some people like to think of it as being nothing more than the way that you move to a specific subset of the dimensions below the 10th. All of these, I believe, are different ways of expressing the same important ideas about the underlying, enfolded, fractal, recursive nature of our reality or any other. Last blog was called Suffering in the Multiverse. In it, we took a mind-boggling journey guided by philosopher David Pearce through the moral implications of the set of all possible states, which we're talking about here. Next blog, we're going to narrow back down to the idea of there being a selection pattern, which is choosing our universe from out of all possible universes, an idea that we touched upon recently in the biocentric universe. In fact, our next blog will be called The Biocentric Universe Part 2. That's all for this time around. My name's Rob Bryanton. Enjoy the journey.
Hi friends. Due to popular demand, the book that started this project, Imagining the 10th Dimension, is now available as an audiobook. This set of MP3s totals over 6 hours and is the revised and expanded 3rd edition of the book. Go to 10thdimension.com/digital.